This is the mission director. Go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. Merry Christmas, BTS.
And here we go. We've had a successful liftoff of the Falcon 9 vehicle carrying the GPS-3 space vehicle into transfer orbit. We're a little bit less than a minute into our launch, and we're preparing for that point of maximum aerodynamic pressure known as maximum Q.
Vehicle is supersonic.
And we've hit our point of maximum Q. These are the strongest loads the vehicle experiences during liftoff. At this point now, it's just an easy acceleration up into our desired transfer orbit. All is looking good with the stage 1 trajectory.
Experiencing maximum aerodynamic pressure.
Now we'll have a very busy next 90 seconds. We have 3 events coming up: main engine cutoff, stage separation, and second engine start number 1. That first event, main engine cutoff, or MECO, is where all of the 9 Merlin 1D engines you see roaring right now on the screen on our Falcon 9 first stage are going to shut down. This is then followed by stage separation, or the separation of our first and second stages. And finally, the second engine start, where our MVAC, our Merlin vacuum engine, on the second stage engine lights up. You just heard now, we're starting to pump cold liquid oxygen through the plumbing of the MVAC engine to prepare it for ignition, just like we did with the Merlin 1D engines before liftoff. And just a reminder, we're not going to be recovering that first stage. So after stage separation, we'll be providing no views of that first stage, only the second stage and the payload. Those 3 events are going to occur in the next 10 seconds.
Stage separation confirmed.
And ignition.
All right, this is great. We've had a successful MECO, stage separation, and SES-1. Our next immediate milestone is the fairing deployment. We're going to expose the GPS-3 satellite to the vacuum of space. And at plus 3 minutes and 21 seconds.
Fairing separation confirmed.
And there you see the 2 fairing halves have separated and fallen away from the vehicle, exposing the GPS satellite to space. You can also see one of the fairing halves fall back into the atmosphere in the camera view right there. Everything is running nominally from the second stage to our payload.
Acquisition of signal per meter.
You can see on your screen the MVAC is continuing to burn, raising the highest point of the second stage's orbit, which is also called its apoapsis. Now, during SECO 1, we'll shut down the second stage's MVAC engine, which you can see again on your screen here. Now, after we shut down the second stage engine, we'll enter into the first of 2 planned coast phases.
Stage 2 is following a nominal trajectory.
Now, we mentioned this a little bit earlier in the webcast, but we're deploying today's GPS-3 space vehicle into a highly elliptical transfer orbit with the final intended target for the spacecraft being medium Earth orbit, or MEO. Now, for those of you who have followed our webcast, you may be more familiar with the terms low Earth orbit, where the International Space Station is, and geostationary orbit, where many communication satellites reside in space. Medium Earth orbit is nestled between these two at an altitude of around 20,200 kilometers, or about 10,900 nautical miles above the Earth. Once the GPS-3 space vehicle separates from the second stage, it will use its own onboard engines to raise the lowest and highest points of its orbit to approximately the same altitude in that MEO range. That maneuver is referred to as circularizing its orbit. Now, a fun fact here, GPS satellites are tilted with respect to the Earth's equator by about 55 degrees, and that allows them to provide coverage to the Earth's polar regions. That orbital tilt is referred to as an orbit's inclination, and it takes extra power from the launch vehicle to safely reach. That high inclination orbit combined with the large payload mass are actually why we needed to reserve all of Falcon 9's performance today for the primary mission, and why we did not attempt to recover today's first stage. Now we're just under 2 minutes away from SECO 1. Again, that's second engine cutoff number 1. MVAC engine is still burning bright, burning that RP1 and liquid oxygen. And we're continuing to boost the GPS-3 space vehicle into that highly elliptical transfer orbit.
And the MVAC is still firing, and we have just about under 30 seconds to go before that SECO 1 milestone.
From a camera mounted on the side, gives us good visibility and a visual confirmation of engine start when that event happens. So again, less than a minute away before second engine start number. There you can see on the screen, relight of the second stage engine. That's a very short burn, lasting just about 45 seconds. That's because the MVAC is still producing just as much thrust as it was before, but it's significantly lighter now because we've consumed so much propellant on the way up. And there's confirmation of MVAC shutdown. That's second engine cutoff number 2. And we're just going to wait for confirmation of a good orbital insertion.
Nominal orbital insertion.
minute away from satellite deployment. Now after deployment, the spacecraft will use its own onboard thrusters to slowly raise into that circular medium Earth orbit. Kind of cool here, we're almost at 8,500 kilometers.
So we're going to watch, we're expecting within the next minute to get a visual confirmation and a call-up confirmation of that payload deploy.
You can see the spacecraft on your screen there.
Spacecraft separation confirmed.
And there it is, a successful spacecraft separation. You can see the space vehicle gently floating away to continue its mission and achieve that medium Earth orbit. And with that, SpaceX has achieved our primary mission, which will bring our webcast here to a close. We'd like to thank the Air Force for trusting us with this mission, and we look forward to the future GPS-3 satellite missions in the future. Also, we want to thank the satellite manufacturer Lockheed Martin. A special thanks also to the 45th Space Wing for range support, and to the FAA for the licensing of today's mission.